Yeah, what, 2003, question 2. This is a calculator problem. A particle moves along the x-axis so that its velocity is given by the following equation. V of t equals that stuff. At time t equals 0, the particle is at position 1. Guys, that's an initial condition. It is telling you x of 0 equals 1. All right, that is an initial condition for a fundamental theorem of calculus calculation. Somewhere later in the problem, it's going to say, hey, where's the particle at time 3? Or something, okay? It's going to ask that. Letter A, find the acceleration of the particle at time 2. Is the speed increasing at time 2? Let's start with getting the acceleration. Guys, I would use my TI-84, right? And I would find A of 2 being B prime of 2. You guys all agree? So we'd use our derivative key, all right? And if I type that derivative of that function, negative t plus 1 sine t squared over 2, comma x, comma 2, it's going to pump out 1.57, 5.87 something. 6? Okay, and they gave credit for 1.587 or 1.588, so this is why we go 4 decimal places. All right, that is worth a point right there. Now, the next thing is asked is the speed, not the velocity. Is the speed increasing? Guys, if it asks for velocity, you would look at a positive acceleration and say, yep, its velocity is increasing because A is positive. Speed is not velocity. This is the idea that if you're driving in reverse and you're accelerating, your speed is increasing. If you're driving in the reverse and you're braking, your velocity is increasing. Because forward is positive, okay? So in this case, I have to figure out what V of 2 is. Now, when I put 2 into the equation, and you've got to be in radians, when I find this, I see that V of 2 is equal to what? Negative 3 sine of 2. And when you put that in your calculator, all I care about, guys, is that this is less than 0. So let's be clear. The velocity is negative. The acceleration is positive. Thus, the speed is decreasing. Okay? So the answer here is speed is decreasing. And the reason is A of 2 is greater than 0 and V of 2 is less than 0. All right? So speed is decreasing with reason is the other point. 2 points here. All right? Does that kind of make sense to everybody? All right. And again, I will tell you right now the velocity was increasing, but they didn't ask for velocity, they asked for speed. All right. Question B. Letter B. Find all times t in the open interval 0 to 3 when the particle changes direction. Justify your answer. Okay, guys. A change in direction, okay, occurs when there's a change in the velocity, right? So if you're going to find all the spots, you got to set that equal to 0. So you need to find all the zeros of V of t equals 0. So the first thing, write that you want to find the zeros. All right. So I want to find this. All right. Justify your answer. Okay. So start with this, guys. Do we agree that 0 equals negative t plus 1 sine of t squared over 2? And I'm going to make sure we notice this. Now, remember, guys, this is basically a product of 2 functions. This is a product of a linear function, I underlined in red, and a product of a trig function, I underlined in blue. Let's be clear, for the domain of 0 to 3, the red portion is never 0. You guys agree? So really, all I have to do here is find when sine of t squared over 2 is equal to 0. Now, you guys can type this in your solver, all right? It's going to give you a decimal, all right? I know that sine is going to be 0 in this case. I could do this longhand, or I could do this with my calculator, all right? I would probably do it with my calculator, and I would get t is equal to 2.506 something. Really? Let's take a pause on the video and try it. All right, so I just put up a little picture of the thing. So I get 2.5066. There's the time. That's when the velocity equals 0, okay? And then all you got to do is show that there is a sign change. You guys agree? On the velocity. You got to show that it's either negative or positive. And think about it. Didn't we show on letter A, at time 2 it was negative? Letter A. So I could write v of 2 is less than 0. You guys agree? And I would actually write from letter A, because that's where it came from. You guys agree? And then all I have to do is I would plug in v of, say, 2.8, and I would show that that's greater than 0. Okay? Thus, the particle changes directions from left to right at time, right? Because it's going left when it's negative, right, guys? From left to right, because it's on the number line on the x-axis, at time 2.5066 seconds. All right, the points here on this one is the time, and then the reason that you have to show probably these facts to get the second point, guys. You have to show that you understand that there's a velocity, that the velocity has changed directions. All right. So 2 points on this one. And again, if I group all this stuff, all right. And again, I think these get easier once you've seen them a couple times. Letter C, find the total distance traveled. Now, this is something we were talking about yesterday, from 0 to 3. Guys, total distance is not just the integral from 0 to 3. If you do the integral from 0 to 3 v of t dt, you're not finding the total distance. You're finding the total displacement. Your calculators are amazing machines. I know, John, we talked about this yesterday just before you walked out. You can do this in your calculator, and it will give you the distance. All right? Now, the only other way to do this is a non-calculator section. You guys agree we found the 0? You could do this using the time of 2.5066. But you'd have to break this integral into 2 parts, right? The distance from 0 to 2.5066 v of t dt, and this will be a negative number. So we'd make that a positive, and then we'd add the integral for the positive direction. All right? And maybe I put that in absence. But guys, there's no reason to work this hard on a calculator section. This would be the first part of this integral here in red would be the derivative, or not the derivative, the integral would give you the distance of travel going backwards. This would give you the distance of travel forward. Again, it's going to be under math, and mine's called ABS on my own calculator. So we can set that up here. So I'm going to write distance equals, and I'm going to write just this, and then I'm going to write an answer, guys. And I'll pause the video and we'll put the calculator on again. So I'm having a little problem getting, my calculator had 333. What's the fourth decimal place? With 3 again? No. 8. Right. It gave credit for 4.333 or 4.334. Okay? So that's the answer. And you get, oh wow, you get a ton of points, guys. Listen to this carefully. You get a point for 0 to 3 for your limits. You get a point for the integrand, the absolute value of v of t. And you get a point for your answer. All right? It's an easy one, too, again. And we keep thinking to ourselves, if I can get 2/3, if I can get 2/3, you're on your way to a 4. Okay? Well, for a 3, it's not that much less than 2/3. We go for 4. Go for 4 and miss, you get a 3. All right, so let's group this. All right, last one. During the time interval of 0 to 3 for time, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. Guys, you see how it says greatest distance? we're going to optimize, all right, because we want to find the greatest distance, right? We're going to find a max or min or optimize. We're probably going to find a max here, actually. Everybody, think about this. We're talking about the greatest distance. For letter D, we want to find the greatest distance for x of t. The derivative of x of t, guys, is v of t. And since that's a differentiable function, we've already found the critical point in 0 to 3 in letter B, right? So right away, we can write v of t equals 0 at time equals 2.5066, right, seconds? And this is a critical point. You guys all agree? And think about it. On letter B, we've already told you that v of t goes negative to positive. You guys agree? We already did this on letter B if you look back up at your work. All right, if it goes negative to positive, what do we have? And if I try to get in the camera here, negative to positive, right? Think of ourselves going negative to positive. It's a local min, right? So, all right, yeah, so negative to positive, we have a local min. So now, we know that we have to find the greatest distance here. We're going to have that a capita at that point. We're going to be the furthest away. So, what I can do, let's think about it, guys. The particle's on the origin. When I say local min, it's the biggest negative value. Think about it. That's as far away from the origin as it is. You got to think of a number line. The farthest value, if you're at a local min, you're actually the furthest away. Because then the particle changed direction and came back this way. At time 2.5066 seconds. So, I have to do the fundamental theorem of calculus, which, guys, at this point, we know we would have to use this initial condition. Right? We haven't used it. Why give it to us if we're not going to use it? It has to be in the back of our mind. So, I'm going to set up the integral. X of 2.5066, right? That's going to equal x of 0 because you have the integrant, so you have to give it an initial condition. Plus, the 0 has, this number has to match, right? So, plus the integrant of 0 to 2.5066, v of t dt. It said x of 0 was 1. And guys, this, if you do this integral in your calculator, right? Again, using the TI, I get negative 3.265 something, and I don't have that decimal, fourth decimal, but I get negative 2.265 for x of 2.5066. Now, everybody, you can't just say that's the answer. You can't just say that's the answer. Because this is an extreme value theorem, right? You have to evaluate the endpoints. You've got to check x of 0 and x of 3. All right? So, if I check those, now first of all, x of 0 is easy to check. X of 0 is 1. Right? So it's nowhere, okay? And if you think about it, guys, if you check x of 3, you probably don't have to do it this way. If you do the integral x of 3, you're going to get the value. But does everybody agree that the distance it traveled in the last problem was 4.334 total? If you take 4.334 total, you're going to see that when you add to this, it's smaller than that. But if I do it, I probably would do it this way. Maybe I'll just do it this way. I could use the distance traveled in the last problem. Now, this time you do want the total displacement. Okay? This time you do want the total displacement. And if I do the math, nope, because when you do this now, it's displacement. When you do it without the absolute value signs, all right, you end up at a number, and I guess here's what I would do. I would just, it comes out less, so I wouldn't even bother writing. Everybody, since I'm looking for the distance from the origin, I'd use absolute value sign, right? Because absolute value means distance. And the result of this is less than 2.265. All right? That said, when I do this math, guys, all right, I show that x of 1 is 1. I showed x of 3 is less than the absolute value of 2.265. So the greatest distance from the origin. And guys, this is the hard part of this problem, because think about it. We're using a negative number being the greatest distance from the origin. Because we have to get our mind around this particle moving on the x-axis. It is difficult. This is a hard part of the problem. It's only worth 2 points though. So the greatest distance occurs at, what's the question asked? What is the greatest distance? The greatest distance, I don't want the time. So the greatest distance is 2.265 at time equals 3. So everybody, that's the answer, okay? That's the greatest distance. Again, it has two things going here in the last one. You have to use the extreme value theorem. You have to use the fundamental theorem of calculus. You get 1 point. You get 1 point for the distance of 2.265. You get 1 point for showing the endpoints, guys. All right? That to get the answers that you considered, okay? So, listen, this problem had I think two really easy parts. I think this one had A and C that were easy. A was worth 2 points, C was worth 3 points, right? That's 5 out of 9. This might be one where you're going for half, you know what I mean? Or some of the other ones, you gotta get your 9 for 9.